Okay.
Hello, hello. How goes it?
Yeah, he said.
I'm just gonna roll with this. I don't know what's happening.
Yes. He was on vacation, so last week.
I'm gonna throw everybody into the attendance sheet here. What was your name? Brandon? Jorgensen?
Yeah,
Yeah. Okay, cool. You exist.
yeah, he was on vacation when. I think it's close, so
No problem. Not the end of the world.
he's good to go.
Yeah, all is well.
Cool, thank you.
Good morning.
Morning, sunshine.
How you doing, buddy?
Well, you know, I'm good. Tired, cranky, the usual.
Perfect. Yeah, did you get my email?
Yeah, I just got it.
Excellent. Okay, cool.
Yeah,
All right then, brother. Just wanted to keep you informed on that.
yeah, I appreciate it. You're good.
All right, bro.
And I'm awful with names. What was your name again, dude? Joseph? Okay, cool. Trying to not do a sign-in sheet and remember people's names this week. Really bad with names, like god awful bad with names. I feel awful about it. I tutored for so long. There were some people I tutored for like 2 years, don't remember their names, don't even know if I got them, honestly, I have no idea. It's really awkward at work when everybody's like, oh, hey, whatever, like, they all got hundreds of donors' names memorized. I'm like, you're that guy, I know your face. Like freaking, I can remember what video games some people play, but apparently not that. All right. Come on, pen. You can write. I believe in you. I really don't. Here's the link.
So, Mr. Ben,
Oh my God, that was loud. Yeah, what's up?
I have a quick question. So, are you a fan of like the Big Bang Theory and or Young Sheldon?
So I am not, because I am a nerd and I understand everything that they're talking about, and I'm like, oh God, you're breaking everything. Oh God. Did I just destroy what you were gonna say?
I destroyed my question. Yes,
Okay, that's fair. I'm
because I was
sorry.
gonna ask you because they go over how zero's not a number.
I mean, kind of, it's more of a concept. But yeah. I
And I
mean,
was
it depends
gonna
on your
ask you
definition of
if you-
number. I mean, by our definition of number, it's a number. It's a number because we said it's a number. English is weird. English is a very stupid language. My favorite name is Sean Bean, because his first name and his last name are spelled exactly the same except for one letter. I'd like him to be Sean Bean. Sean Bean. All right. Well, in case you want to know how prepared I am, I spent the last, honestly, most of the day writing out basically the next couple of weeks. Like, woo! I got 81 slides. I still have, I still have to separate problems out between what I expect people to do in class and what I expect us to do together. But as you might have noticed, I have a terrible memory. So when it comes to what we're doing today, I forgot to write it down. just gonna write fractions there and we're just gonna call it good. Just gonna go like this. Okay. And for the record, since you haven't been here, if you have any questions, no matter how dumb they are or how dumb you think they are, ask them. I am all for it. Like I used to work at GameStop and I always told people I had two jobs. I had a job where I went and I helped stupid people and I had a job where I taught math. Like that's retail. Retail is, oh God, I hate retail. I wish there was a job where I could just hide in a cave and get paid for it. Cool. So I see that, I've been rambling for 5 minutes and attendance still hasn't picked up. I got 3 online, I got 2 in person. As usual, second week, cuts in half, like it. This class drops like nothing. Ooh, oh my God. It's great.
It's good to be here.
Well, it's good to have you here. I missed you, buddy.
I missed you as well.
Are you making both?
Yeah.
You put it back in the-
He's my favorite.
I'll take it. All right. So. I always start off with a bunch of review. I didn't actually decide to put an explanation of long division because we know what division is. You're dividing a number by another number. But let's face it, that giant block of text that I put on the board last time was horrible looking, right? But the actual method isn't bad. So I figured instead of an explanation, just gonna jump straight into it. Only got a couple this time. Also, I love this, my current phone taking a photo of my new phone, knowing damn well that it will end up in a drawer after that. Bye, buddy. Bye. All right. Let's see if I can get my pen writing. It's angry. Don't know why. Okay, so I'll just write them one at a time. All right. And I've said that I'm just essentially reorganizing my class as of this class compared to before. I've decided that when it comes to the review stuff, I'm just going to go through stuff as an example. When it comes to the other stuff that we're seeing for the first time, those are the ones we're going to have me give you a few minutes, you work them out, you ask questions, that sort of thing. But just for the review stuff, I'm just going to run through it. Explanations about. So remember, this symbol is exactly the same as a division symbol. I mainly write it that way. 1, because it's easy to write both division and fractions the same way. And 2, because honestly, it's quicker and I'm lazy. Also, there's a fun one. Oh, no, I guess not. On my stupid expensive calculator that's been with me longer than a huge chunk of my students have been alive. When I hit the division symbol, which looks like what you're used to, it gives me a slash, just like what I'm used to. So that's one of the reasons why I kind of gravitate in that direction. So we're putting 14 into 231. Now remember, you're going to take this whole divisor, that's what it's called, divisor, and put it into the dividend. And for the record, I don't think it matters if you remember what's what. So I don't care. If I have a degree and I didn't have to figure it out, you probably don't either. So we're going to take the 14. We start looking into the digits to see which one it can go into. Can't go into the first digit, but it can go into the first 2. So we're going to start right here and say 14 goes into 23 once. Take that guy, multiply it by the 14 and put it down here. So that row you subtract 23 minus 14. Gonna have 9. And then you bring down the next digit, which is a 1. And we say, okay, how many times can 14 go into 91?
7 times.
7? I don't know about that. Let's find out. Let's put a 7 there. Let's see, 7 times 4 is 28. 7 times 10 would be 70. 70 and 28 would be 98. That doesn't go into 91, so that's too many.
Oh, I was close.
You were close.
Oh, I was just joking. 6.
Okay, well, you had a good joke. You were like half of 14 off. So we're gonna do 6 times 14, 6 times 4 is 24. 6 times 1 is 6, so you'd have 60 and 24, so you'd have 84. Again, you subtract 91 minus 84, and my god awful handwriting, we have a 7. We're excited about the 7. It's our favorite 7 ever. Look at that 7. All right, well, we ran out of digits, so now, you know, depending on the math you're doing, you might say, oh, remainder 7. You might say we have 7 out of 14 left. If you're doing decimals, which, you know, we've been doing decimals, we put a decimal here and then start moving outwards until we're basically content, until we're happy. Like that's really what it boils down to. You just do as many decimals either as you're being told to, which a lot of times is to the second or third digit, or until you hit a point where it ends, or really just whenever you feel like it doesn't suck. Like if I'm doing a long, horrifying, gigantic math problem, I'm usually going to want more specifically precise examples to work with than not. So if this was going to be an answer that I was going to work with after, I might actually go out to a bunch of digits. But again, you're probably also just going to grab a calculator and punch it in. Such is life. But hey, it's a method. We're going to learn it. We're going to have fun with it. So you bring down that 0 and we say, how many times does 14 go into 70?
5.
All right. So 5 times 14 is 70. Subtract that, we have nothing. If we have nothing, that means there's no more division to be had. That's the point where it ends. 16.5 is exactly where you want to be. Yay. Cool. Questions, comments, concerns? No, we're really excited about this. We're happy. We love doing long division. Excited about the prospect of another 2.5 hours straight of math. That's a lie. All right. All right, so the next one we have is 312 divided by 5. I'm going to go ahead and take a guess and say it's going to be 62.4. Probably 62.4. Definitely 62.4. Okay, so 5 going into that sucker. Put the 5 on the outside of that. I always figured that a lot of things in math have very fancy or Greek names or anything, and I kept, you know, somebody's like, hey, what's the name of this symbol? What's the name of that? I'm like, I don't know. No, nobody's ever told me. So I Googled it, spent a little time trying to figure it out. Eventually I found it. It's called division symbol.
Oh,
Yeah.
okay.
Yeah, so yeah, again, everything in math is either named after what it is or what weird Greek guy decided to call it. All right, so 5 can't go into a 3, but it can go into a 31. 6 times. 6 times 5 is 30. Subtract that sucker off. Gonna have 1 here, bring down the next digit, which is a 2, so we got a 12. How many times does 5 go into 12? Oh my goodness, twice. 2 times 5 is 10. Subtract that off. We have a 2. Ran out of digits, so we're going into decimal territory. So the next digit comes down. 5 goes into 24 times.
Okay. Thank you.
Yep, we're done. Anybody want to know how I half-assed that division in my head?
Yeah.
Okay,
'Cause you
So-
broke it down.
312 divided by 5. How many times does 5 go into 10? Twice, right? Well, it's happening 31 times. So I'm gonna have that happen twice, 31 times. 2 times 31, 62. Okay, so that's 62 right there. What do I have left over? Oh, that 2 out of 5. 2 divided by 5. It's the same as 4 out of 10. So it's 4/10. 4/10. There we go.
Wow.
I've kind of tried to challenge myself on mental math the last several years because I've met many people who could not do algebra, but could dance circles around me with this stuff. And I've tried to apply myself and figure some of it out. I'm not gonna lie, not too great at mental math still. But that's the thing, you don't really need to be. You really don't. As long as you have the tools in front of you, you have the calculator, you have the instructions on how to do stuff and what it's useful for, you can generally get the job done. It's all problem solving skills. That's really all math classes really good for, is being able to have decent problem solving skills. Because for the most part, anytime you're going to run into math in the real world, it's not going to be some nice, neat little equation. You're going to have some weird stuff going on. So it's all about being able to apply what you know to what you don't know and figure it out. Cool. So now we have 93.5 divided by 1.1. So we're having fun with fractions and decimals and all sorts of things. Now remember, the way I showed you last time, and again, you don't have to do it this way. This is the long way of why it makes sense. But the way it makes sense is you don't want to divide by a decimal because then it gets really, really murky on where the decimal point is up here. It gets really, really weird. So if we change that bottom one to like a whole number, then we're in good territory. So you would normally multiply this by 10 over 10 to clear out that decimal point. And remember, that is why it makes sense that if I move the decimal point 1 in this direction, I also have to move it 1 in this direction on that. Both of those have to move the same amount of digits at the same time. Josh, I have no idea where you work, but I appreciate that there's a commercial for the Bunny Ranch behind you. Good job. Good job. I'm proud of you.
You're welcome.
Well, you
Yeah,
didn't tell me you
yeah.
were at work, so yeah.
I thought I mentioned that inside my email.
Yeah, all right. There you go.
Well, hey, this is where I
At
work.
least my first reaction wasn't, hey, she looks familiar. All right. Joke about me having morals is really a joke about me being broke. All right. Or, being in a committed relationship with someone who would murder me. Honestly, for whatever reason, she feels like the amount of times I get told that I'm gonna get slapped or punched really high. I told her I'm just gonna earn it. I'm gonna get slapped anyway. Might as well have fun with it. All right, so 11 into 935. 11 into
That's the spirit.
93. Probably 8, right? 88. Throw that in there, 8 times 11, we get 88. Subtract that guy off. 93 minus 88, we get a 5. Bring down the next digit, we have a 5. Oh my goodness, how many times does 11 go into 55? You guys know that one, right?
17 times.
I feel better. If you couldn't see the 5, I would be concerned. All right, so 5 times 11, 55. Subtract that off, we get nothing. That means it went in evenly. Yup, and even though we moved that decimal point over on our original, that's still, since we moved it over the same amount, it's still an equivalent answer. So 1.1 went into 93.5 85 times. How did I make this problem? Oh, I multiplied 2 numbers together and slapped the decimal somewhere. Good stuff. All right. How do we feel about long division? Are we good with it? Are we okay with moving it to the past? We're moving past it. Okay. From now on, you have a calculator. You press one button, you hit the division symbol, you press the next button, it works. But if you're on a really important test and it asks you about how to do that, well, now you know. And also, as I showed you last time, not for long because I knew it'd melt your brain, but once you get to crazier algebra stuff and you do long division with polynomials, one, you can't slap that into a calculator unless, oh, I don't know, you spent 150 bucks on it. Or, it's funny because you can find these in pawn shops for like $5 sometimes. Yeah, you're just stuck doing it the long way. So long division will come back if you continue going with your education. It will come back and it'll be uglier looking and it'll be easier. Annoyingly enough, it is easier that way. Yeah, it really is. Like the amount of like 14 into 90, not going to happen. Not something you're going to think about. It's all small numbers and how many times does the variable go into this? It's like 2 into 5 or something. Works out nicer. Okay. So number properties. We did a fair amount of those last time. Remember, we had the commutative properties, the associative properties, and the distributive property. All of them are with addition or multiplication. Distributive, just, hey, you got a thing multiplied by a set of parentheses. Guess what? You can multiply it by each thing in the parentheses. Otherwise, the commutative properties basically say, hey, you got these things either multiplied or added together. Doesn't matter which order you multiply or add them together, they're going to come up with the same thing. So 2 times 3 is the same as 3 times 2. 500 times 1,000 is the same as 1,000 times 500. Doesn't matter how far you scale up those ideas, the concepts are still the same. That's why you use variables, because the letter A is a stand-in for whatever. Letter B is stand-in for whatever. I also have, for no impressive reason, that third line there, it's also true that A% of B is B% of A by the same logic. So you can absolutely find, 8%, what was it, 8% of 50 I used as the example last time, by finding 50% of 8. So 4. So that works both ways. The associative properties are pretty similar. They just don't have you rearranging things. It's basically saying same idea, multiplication and addition. Doesn't matter which ones are grouped together. You can change how they're grouped together. You could do them in essentially the later ones first and then bring it into the first one, or the first ones first and bring in the later one, whatever you want to do. As long as you have those pieces of information added or multiplied together, doesn't matter if you do them all at once, a couple at a time, whatever, as long as they end up having those operations happen to them eventually, you end up with the same thing. It's going to work out great. Cool. So, not a whole lot to cover for these guys. Kind of stretched it, not gonna lie. So, number one, which of the following can obey commutative law? And can any that do not be rewritten to work? So 3 times 12, would that work under the commutative properties? Because if you reverse it, commutative is the one where you can move stuff around. If you reverse it, you know, 12 times 3, same thing, right? There you go. Same with B, 4 plus 20, the same as 20 plus 4. Cool. C, 36 divided by 6, that wouldn't be the same thing as 6 divided by 36, right? That would break. You would be breaking stuff really hard. So that one would not work. D, 36 minus 6, not the same as 6 minus 36, right? So that'd break. And -3 times 4, would that be the same as 4 times -3? Yeah. Even though the sign's a little different, as long as that sign stays on that 3, it'll still work. Now, awkwardly enough, the 2 that didn't work, for C and D, I'm gonna write these down real quick. They can be rewritten in a way to make them work, but it's a little tricky on C, and on D, it's not very tricky. And it involves basically switching the operation around, kind of how we're looking at stuff. So I'll do this one first because it's a little easier to comprehend. So 36 minus 6. Remember I said that addition and subtraction are basically the same thing. Subtraction is just you're adding an inverse. And it's nicer to understand with a minus sign. Well, you can write this as 36 plus a -6. And if I have a 36 plus a -6, I can move those around. And as long as that negative sign stays on that 6, we are good to move it around as we need to. This would be equivalent. So there is a way to write it that follows that property and continues to work. Now, that's all well and good here by changing subtraction to addition and looking at it in a different way. The heck we do is division. Well, division and multiplication are closely related, right? All right, so let's look at this. We have 36 divided by 6. How can I change that to multiplication? Well, let's think about how this would be written if it was like a fraction. 36 over 6. Okay. Now you can actually, when it comes to the laws of fractions, we haven't played around with that too much, but you can separate these things out. You could say it's 36 over 1 times 1 over 6. You can separate the top out of it and take the bottom part and make it its own term. Well, 36 over 1 is just 36. But you can't really make that 1/6 nicer, right? But look what we did. We just changed division to multiplication. If subtraction is the same as adding the inverse, then division is the same as multiplying the inverse. So it ends up working out pretty nicely that way. Now we have something that we could change around how we write it and make it work. How important or useful is this? 50-50. Are you expected to fully understand this concept right now? Not really, but if you do, then it might make some things in the future much simpler. As I said, I went through like Calc 3 differential equations. Didn't always have the best time doing it, but once I started tutoring algebra and stuff lower than that, suddenly the calculus was easier because I realized that literally all of calculus is like 2 steps of calculus and then a crap ton of algebra. So you get these operations down and you basically just look like a freaking wizard. But the downside is that these are the foundations of it, so it's harder to learn. If you don't get it right now, it's tougher to understand. Okay. Let's look at number 2. Which property is applied to this expression? So we have 5 plus 3 in a parentheses plus 12 is equal to 5 plus, and then in a parentheses 3 plus 12. Well, we just played around with the commutative properties, and that was writing things in a different order to show that it would still work. Well, these are in the same order, so it'd have to be the other one, the associative properties, right? Since there's a bunch of pluses, it's the associative property of addition. And what is it there for? Well, it's there to say, hey, if I have on the left 8 plus 12, that's going to be the same as on the right 5 plus 15. You can group them how you want to. They're all getting added together anyway, so might as well do what you're going to do anyway. Okay. Number 3, using the associative property, write the expression A plus 2 plus B in a different way. Well, going back to it, commutative was moving things around. Associative, they stayed in the same spot, but we grouped them differently, right? So if I'm using the associative property on this guy, well, that's just changing not the order they're in, but the association they're with. So we're not going to tie the A plus 2 together. We might tie the other ones together. We might tie the 2 plus B together. Now, another valid option would have been tying the A and the B together. But this one would be strict associative. This one would actually be both the associative and the commutative. Only reason because we had to move stuff, like actually move stuff around. So just think of the word commute and associate. Commute, move. Associate, grouping. That's pretty much the main bit there, right? Okay. Number 4, we should be able to do just by looking at it. If 3 times A times 4 is equal to 3 times 7 times 4, A is equal to 1. Questions, comments? I'm gonna make somebody yell at me on this one. What do we think? Anybody? What does the A mean? 7. Bingo. Is correct, 7. Because we have 3 and 4 multiplied together already. On the right side, we have 3 and 4 and a 7. So obviously the A has to be a 7, even though they're associated differently. On the left, the A and the 4 are associated. On the right, the 3 and the 7 are, but it's still the same 3 things multiplying together. Beautiful, beautiful. Okay, and number 5, evaluate -5 times a 6 plus 10 using the distributive property. Now, I've said it before, but evaluating these things using the associative property makes more sense when you're in algebra, because you wouldn't be able to immediately throw these things together. Right now, the easiest way to do this problem would be to add the 6 and 10 and then multiply it by -5. That's the way I would do it. But if it's strictly saying using the distributive property, that's trying to tell you to distribute, which means that -5 has to multiply onto both that 6 and onto that 10. So we have -5 times 6, -30, right? Because 5 times 6 is 30, negative times a positive is a negative. And then -5 times 10 -50. -30 minus 50, you're already in -30, you're going down 50 more. So you're at -80. And remember how I told you if you're still off on your signs? Remember I told you if the signs are the same, you stack the numbers together and keep the same sign. If the signs are different, you find the difference between the numbers and you keep the sign on whichever one was biggest. Any questions on properties? All right. Into the past it goes. So this one, literally just throwing it in here for funsies. Inequalities don't really come up too much until a little bit later. Not too much further in the future, but I'd like to at least have them here as a baseline. So we're just going to look at the greater than or less than symbols. So the idea there is that they're useful for illustrating entire quantities, one quantity being higher than another quantity. When it comes to algebra, it's very, very useful for giving you ranges of numbers. So the two symbols you look at, greater than or less than, kind of open up towards the larger side. The greater than symbol is kind of bigger on the left of it than on the right of it. And it's saying that the left side of this would be greater than the right side of it. Whereas the less than symbol is kind of pointing to the left, and it's saying that the left one is less than the right one. Here's an actual like visual example. So 3 is less than 5, you can see that right there, and you would normally be able to say, yeah, 3 is less than 5, cool, that's what the symbol means. Or 9 is bigger than 6, 9 is greater than 6. So those would be the directions you'd be looking at the signs. And the whole reason I have them for is some examples is being able to compare a few decimals together, being able to see their place values and being able to compare those. So I have written there, place a greater than, less than, or equal symbol between each of the following. So 2.390 versus 2.389. Which one's bigger? What was that? Yeah, the one on the left. Because if you compare the digits, the 100th place in the left is a 9, the 100th place on the right is an 8. So that would be a greater than symbol. So that would be the terrible plan. Absolutely terrible plan. It's gonna be cheap. Gonna be really cheap. Oh God, the beam's too big. Okay. So yeah, we decided that one was a greater than. And the next one, we have 530.41 versus 529.42. Which one's bigger? Yep. That one I threw on there, not much of a trick question, but it was mainly to illustrate, hey, don't look only at the decimals. So I've seen some people do that, just look at the last, chunk after the decimal point and say, oh, 42 is bigger than 41, and then it breaks. All right, 18.591 versus 18.59100.
Equal.
Yep. And what do we think on the last one there?
67.069.
I hear mumbles. I don't know what anybody said though.
67.069. Greater than.
You would be correct. Would be a greater than. Because we're not looking at the 70, we're looking at the place values. Here we have 0.06, here we have 0.00. Now, is it cheap that I didn't have any less than? Yeah, probably. That's okay. That's okay. Now let's throw things off for the next time I teach this. Cool. Okay, new stuff. We got fractions. I know, y'all love fractions. Everybody's happy with fractions. How you feel about fractions? Yeah, no. Immediately getting the no. Okay. Cool, that's why I do a crap ton of fractions. That's the thing, everybody hates fractions and like, it really just boils down to, it's kind of hard to wrap your head around at first. And then you just try to avoid it for the rest of your life. You see fractions, you're like, that's the point I'm gonna miss. You see it and you're like, okay, well, I'll ask somebody else on this, you know, you avoid it. And the only reason it continues to suck is because you've been avoiding it. So like, I was like that too. And at one point I just decided, you know what, I'm tired of this sucking. I'm gonna sit down, I'm gonna deal with this. And I think it took like 20 minutes, half an hour or something like that. And I was like, oh, this is really, it's not so bad. So I like to teach it the way I understand it because it's not as bad as it looks. It's all about thinking of things as just partials. That's all it is. Like, we understand what a half is, we understand what a quarter is. 3/8 is kind of weird, but you know what? If you have a ruler handy, you know what 3/8 means. It's 3/8 of the way to the 1. I mean, doesn't have to be too bad. So there's 3 general ways you're going to look at types of fractions. The first 2 are basically the same. We got proper fractions and mixed fractions. Mixed fractions are literally a integer number and a proper fraction. So I don't like having its own name. And improper fractions are also an option. So proper fractions are basically nice looking fractions. You have a third, 3/8. You know, it doesn't sound as nice, but say 7 out of 150,007 or something like that. You know, you have the small number on top, big number on bottom. Mixed fractions are a combination of an integer and a proper fraction. So you just have a number and another fraction there. So like 5.5. How far is this away? Oh, it's about 6 1/10 miles or something like that. So that would be mixed fractions. It's basically 2 pieces. And then improper fractions are, well, the other way around. You don't have the bigger number on top or on the bottom. You have it on top. So you end up with a larger number in the top than the bottom. 15 out of 4, that's an option. Hey, how far away is this? Oh, it's 18/3 of a mile. No, improper fractions are terrible answers for word problems because it's something you would never just say to somebody. You know, how far away is something? You could say it out loud and you say 15/4, you're gonna look like a jerk. So you just figure out the mixed fraction for it. So proper and mixed fractions are the easiest to understand, but when you're actually working things out, you generally want to end with a proper or mixed fraction, but when you're doing the math of it, you're going to use either proper fractions or improper fractions. You're not going to use mixed fractions. Mixed fractions are specifically very difficult to do math with because, like I said, it's 2 pieces. You basically have an invisible plus between them. If I have 1.5, I have 1 plus a half. That makes multiplication and all these things go absolutely bonkers. Like, it can be done, but you're going to be using the distributive property a lot. So just make it an improper fraction and call it. Okay, so before we get into playing with those, let's see. So I just have 2 slides on how to deal with fractions, like just the basic adding, subtracting, multiplying, dividing, because that's really what everybody has trouble with, right? Oh God, when do I do this? When do I do that? I forget if it's when I do this or I forget if it's when I do that. And it turns into this weird jumble. So adding and subtracting, same concept. You have to have a common denominator. It's like you have a quarter of a pie in a pie pan, you're trying to save room and shove them all into one pie pan and after a party or something into a fridge, and for some reason you haven't eaten it all. You got like a quarter of one and then like a third of the other, and you put them together and somebody's like, exactly how much pie is that? I don't know. This one's a quarter and one's a third. But if you have them in the same perspective, if you have them in twelfths, then it's easier to understand. So if you get a common denominator between the two fractions, then you can just keep that common denominator throughout and add the cross on top. So once you find it, you just go across on top. If you can clean it up afterwards, great. If not, whatever, we're good. So both of those, common denominator, and then go across on top. Now, funny enough, I think multiplication and division are a lot easier with fractions than adding and subtracting. Because multiplying fractions is incredibly easy, you just go straight across. Like top against top, bottom against bottom, you just multiply numerator to numerator, denominator by denominator. That's it. And I have here, reduce the product if possible afterwards. So if you can clean it up, clean it up. Now dividing fractions is kind of a funny thing. Dividing fractions, the entire method is you don't want to divide fractions. Now, it's easy enough to think of, have an example of dividing fractions. I always like to say, hey, how many times does 50 cents go into $2? You would say, okay, 4, right? Because you think of how many times 50 cents goes into $1, and then you multiply that by how many dollars you have, right? Cool. Did you just divide in your head or did you multiply? You multiply. That's exactly what you do with dividing fractions. You do not want to divide fractions, so you change it to multiplication. You leave the first one alone, and then you flip and multiply the second one. So instead of dividing, you actually change it to multiplication. And once you've done that, you just go across like the regular multiplications. So it's literally the same as multiplying, just one more step. So it's not bad. It's really not. Let's do a couple. Don't be part of the problem, be the entire problem. All right, so I'm going to do the first 5, and then I'm going to make you all suffer and do the other 4. It's going to be great. You're all excited by this idea. Yeah. Happiness. I'm going to go ahead and write them all down because they are not going to be bad. Now, when it comes to the second and third ones, I am leaving a little bit of a gap if you're writing them down as well, between the numbers and the symbols, because we're going to need a little bit of space next to them. And if you don't, you could just do what I did in school and write really tiny and cram it in there, because whoop-de-doo. I feel sorry for every single one of my teachers. Then for number 4, notice that I am, instead of just using the slash, I have the division symbol there, because that's a fraction divided by a fraction, as you would expect. I'll go ahead and switch over here. So, number 1, 14/6 minus 12/6. We already have a common denominator, right? Bottom is the same, so they're in the same perspective. That just means that you can add or subtract straight across already. Whatever your answer is going to be is in 6. What's 14 minus 12? 2. So again, adding and subtracting fractions, you get a common denominator, which we already have. Then go across on top. Now, at the end of everything you do, fraction wise, you're gonna look at that and say, can that reduce? Which in this case it can. Now reducing means if you're looking to see if the same number can fit into both the top and the bottom. Because in this case, 2 actually goes into both of these. 2 goes into this one once and 2 goes into 6 3 times. So this one can reduce to a smaller fraction of 1/3. And if anybody has any questions, feel free to throw them at me. They are appreciated. Next one, we have 7/3 plus 5/7. How exciting. Well, these are not in a common denominator, right? I'm adding, I have something in thirds and something in sevenths. I need them to be in the same perspective. So what you have to do is find a common denominator. You think about, hey, what's the first number that both 3 and 7 would go into? In problems like these, a lot of times you can get away with multiplying the numbers together and that'll work. If you have bigger numbers, then that usually makes things more of a headache, but technically it's the first thing they both can go into. In this case, it's going to be 21. So you're going to multiply each of these by something over itself to get it up to that 21. In this case, we would have to multiply it by 7/7. And on this one, we would have to multiply it by 3/3. That way, the denominators on both, we have 7 times 3 and 3 times 7. Those are both going to be the same number. So we end up with, now remember multiplying fractions, you just multiply straight across. So we'd have 7 times 7, 49 over 3 times 7, 21. Plus 5 times 3, 15 over 7 times 3, 21. And yes, I know that's the ugliest 4 I've ever done. I tried to fix it. I made it worse. I'm gonna leave it. You can all deal with it. Okay. So now we have a common denominator. So our answer is going to be over 21. And we're going to go ahead and add a cross on top. So we have 49 plus 15. That'd be 49, 59, 64. Now, might not be the prettiest thing to try to think of reducing, but if you think about it, 21 is just 3 times 7. All you have to do is really see if 3 or 7 goes into that 64. Neither one's going to. So that would be it. Okay.
So not all fractions need to be reduced.
Not all of them, no. Like, for instance, this 1/3. Can I reduce that? No. So if you get down to the point where you no longer have to reduce it, like there's nothing to reduce with, then you're done.
Okay.
Oh, and your name is popping up as Zoom user. What's your name so I can put you in the attendance?
Cecilia. Did you hear me?
Yes.
Okay.
Yeah, I'm just gonna type that into my spreadsheet dealie real quick.
Okay.
All right. So we have on this next one, we have 6/7 minus 2/14. There's actually a couple of ways we can do this one.
Can't you reduce 2/14?
Fine, just get ahead of me, why don't you? Yeah, you can. So yeah, one of the ways you could do it is that 2/14 can reduce. 2 goes into itself once, 2 goes into 14 7 times. So now we have a common denominator, so you're just gonna go across 6 minus 1, 5. Now, real quick, if you didn't see that, you could reduce, and you got a common denominator, which in this case would be 14. You would end up with 10/14. And that is something that you can reduce, right? 2 goes into there 5 times, 2 goes into there 7 times, you end up with the same answer. So what ends up happening is that you still end up doing subtraction and reducing. Just in this case, you reduced first and then did subtraction. Here you did your subtraction, then reduced. So the same operations are happening one way or the other. You're just doing them in a different order. Case in point, one way we could have done number 1 is notice that both of them could have been reduced to the same common denominator. This could have been a 7/3 minus 6/3, which would have gotten us to that 1/3 a lot quicker. Does that make sense? I'm gonna assume it makes perfect sense to everybody. You'll never have to have it explained to you again. It looks great. Okay. Well, number 4. 3/4 divided by 2/3. Okay. Remember, the way you divide fractions is that you don't divide fractions. You're going to change it to multiplication and flip that second one upside down. At this point, all you got to do is multiply straight across. 3 times 3 is 9. 4 times 2 is 8. Nothing would reduce there, so we are good. Dividing fractions isn't bad. Huh? It's a lot nicer than you're probably all worried about it. Just flip the second one upside down and multiply. That's it. Don't stress it. Don't make it any harder than it needs to be. And now, after all of that, after we've done multiplication as part of other problems, how do I multiply these two numbers together? Nothing fancy, just multiply straight across. 6 times 2, 12, 5 times 5, 25. That's a bunch of 5s, that's a bunch of 2s and 3s, so no reducing happening. How do we feel about this? Doable? Sucks a little less? Okay, still sucks. All right, I'll take it. But doable. That's what I'm shooting for. I just want you guys to hate your life a little bit less with this. If I've done at least a little bit of that, then I'm somewhat competent in my job. Well, this job. That doesn't say anything about the other job. I don't know. I don't know, I haven't stabbed or anybody's vein in a few days, so whatever. Oh my God, the ways I terrify people when I'm doing phlebotomy. I'll just come up to them with the needle lines on the end of a tube, like yay big, and then like, I'll be ready to, normally everybody's checking, make sure it looks good, and I'm just standing there swinging it like an idiot. Like, don't worry, we're gonna be good. You wanna be the center's first running start? We could do this. They're not happy with that. I'm a phlebotomist at a plasma donation center. So, it's fun. They all make just as much as I do in a week as, I do here. So I get paid for 5 hours a week. They go in there for a little hair over 2 hours a week, make $100. That ain't bad. I need to start doing that. It's the other side of town. I don't want to go in there when I'm not working. All right. So, hey, look, 6, 7, 8, and 9 have instructions of doing it alone. Oh my goodness. Oh God. So you know what you guys are gonna do right now? I'm gonna shut up. It's gonna be very difficult for me if you can't tell. I'm gonna shut up. You guys give these ones a shot. 6 through 9. If you have questions, go ahead and ask them. Otherwise, I'm just gonna, pretend I'm functional and check my phone.
Are we adding 6 and 7?
Yeah, so we got that plus in the middle. We got 2 pluses, we got a times, we got a divide.
Got a question.
Yeah,
9.
yes, sir.
So I divide it straight across, right?
You don't divide straight across. Remember, the way to divide fractions is don't divide fractions. You keep the first one the same, you change the operation to multiplication, and you flip the second one upside down. So in that one, you're going to multiply it by 5/3. All right, it's probably been long enough. How's everybody feeling? Horrible? Not horrible?
Little,
Little horrible. All right, taking it from the top, number 6. Anybody need to see that one? Need to work it out? Do we have questions? What did we end
Yes.
up with?
Yes, please.
-7/3.
See, a lot of you guys ended up with the 7 and a 7/3, but that one was a little bit trickier.
Was it negative
Not being
one?
-7/3. Actually, it ends up being -1.
How is that? If I'm so confused.
It's okay. You gotta suffer a little bit to make your brain like, oh yeah, I gotta understand this. Until then, you're not. It's gonna hurt a little bit, but that's okay. Because that negative is on that 5, right? Now, we're not multiplying to get that sign. Now, we have a common denominator already, so we know it's gonna be over a 3. The main thing is what's happening on top, right? On top, you think of this minus as being on this 5. That's a -5 plus 2. Yeah, see that? So you end up with basically a -5 plus 2 is the same as 2 minus 5. You end up with a -3. And that sucker reduces very nicely to a 1.
Wow, I didn't catch that.
Almost
we-
like that was my plan all along.
Can we rewind that again?
You know, the fun thing about rewinding is that I grew up in the days of the TV cart being rolled out for class. And like with the VHS and like this is probably too much, but there's nothing like when you get shown a video of a birth on a VHS when you're doing it. Because remember, if you didn't hit stop before hitting rewind, it showed you the tape in reverse. So that was a very formative memory for me, is just right back in there. All right. So again, now that I put that in your brain. Yes, we are already all over thirds. We have a -5 right here. Consider this a -5, a -5 plus 2. -5 plus 2 is a -3. And 3 divided by 3 is a 1. How do we feel about this?
Good.
Good.
Excellent. Have I overshared yet?
Not yet.
Okay,
I didn't see the -1.
that's okay. Let's see. Yeah, it was a little small. Let's jump back over here. We're just gonna, oh my God, that's making a problem.
I see the negative now.
That's causing a problem. That's really causing, okay, how do I fix that? Ugh. Let's do this. Let's do that. Oh my God, did I really double space all of these? Oh my God, what was I doing there? Oh my God, just messing up my own formatting now. I don't have a problem. You guys have a problem. I don't know what you're talking about. All right. Oh my God. Yes, this is legitimately driving me insane. I kind of apologize, but I also kind of don't. I end up breaking out a ruler on my screen here. Yeah, good enough, whatever. All right, I'm cool with that. I might do that. Ooh, if it's a metal tape measure, wonder how that goes pushing it up against the screen. That'd be fine. It's not like the old days of CRTs when you used to go up to it and go zzz.
Yeah.
All right, so before I get distracted by myself again, number 7, how do we feel about that? Do we need to see it?
Pretty easy.
Let's see, that one. 9 plus. Should have ended up with 25/12.
On the way.
For number 9,
7.
25 over 12.
Yeah,
No. No, I did.
all right, let's do this. Also, I could be slightly wrong because I just did that in my head. Yes, sir.
Was it divided plus?
Huh?
Was it divided plus? I can't really see this.
Oh, these guys? Oh, this is a plus.
Okay.
Not big enough.
That's what she said.
No, that's what I said, and then I cried. All right. I'm gonna end up getting a talking to about all the discussions that come out of this class. All right, so we are adding 2 fractions. We have 3/4 plus 4/3. Look at those beautiful fractions. Let's add those suckers together. First, since we are adding two fractions together, we do need a common denominator, yeah. The clicking starts happening around the room. This is where people have their mics muted, so they don't, so we all don't hear their, crap. All right. So we need a common denominator between 4 and 3. The first thing that they would both go into would be a 12. So we're going to multiply this one by 3 over 3 and this one by 4 over 4. And when it comes to multiplication, we go straight across, right? So this one ends up being a 9 over 12 plus 4 times 4, 16 over 12. And that's where your 25 is going to come from. Because you have a common denominator, you can now add straight across 19 or 16 and 9 gives us a 25. I expect that most of you made a mistake somewhere along those lines, yeah? Yeah, exactly. That's why I gotta make you suffer through it a little bit. Because it makes sense when you're looking at it and you're, we're working it together and I'm explaining it, but then you do it on your own and it gets a little rough. And that's fine. That's literally how you learn math, is you just kind of suffer through it a little bit. And then you move on to the next stuff and you suffer through that, and you move on to the next stuff and you suffer through that. You look back at this stuff and you're like, God, I wish I was still doing that. And that's literally all of math.
I have a stupid question.
Hey, I'm down. What you got?
Why did you put a 4 over 4 and 3 over 3?
Okay. So because we are adding two fractions together, we have to have a common denominator, which means the bottoms of these fractions have to be the same for us to add them together. So what we have to do is we have to find a number that both the 4 and the 3 go into evenly. In this case, we say it's 12 because, well, 4 times 3 is 12, right? So 12 is divisible by both of those numbers. Now we multiply this one by 3 over 3 because on the bottom, 4 times what is going to give us that 12? Well, the 3. And the reason we multiply it by the same thing over itself is because, well, what is 3 divided by 3? We just kind of did that, right? It was a 1, right? And even though it's, it's technically a 1, it's a funky looking 1, but 1 times anything is itself. So you can get away with multiplying just on this one, the 3 over 3, because we're multiplying it by an ugly looking 1. If I reduce this fraction, it would end up at that 3/4 again. So it's still an equivalent number. Same thing over here with this 4 over 4. We need to have a common denominator of 12. So we take this 3 and multiply it by, well, it needs a 4 to get to 12. So we multiply by 4 over 4 to make this multiplying by 1. So we make something equivalent. So if I reduce this thing, I end up with that 4/3 again. Once you have them both in the same denominator, you can say, hey, my answer is going to have that denominator, and you can add straight across on top.
Okay.
Hey,
Right. Thank you. Thank you.
you are all welcome in the weirdest way that you want to experience me saying you're welcome.
Okay.
Preferably just uncomfortably so. Okay. I have the feeling I'm gonna do number 8. I don't know. I don't remember what number 8 is. It's been all of a minute since I looked at it, so okay. 2/3 times 4/5. Did everyone get 8/15? Okay. Let's do this. If even one.
That was my first answer, but then I just switched it right now.
Yeah, that's actually one of the many reasons why I never got 100% on a math test. The amount of times I went back and like, God, that can't be right. Go back, erase it, change your answer. Nope, you're right the first time. The amount of times you're right the first time, really high.
Yeah, oh yeah.
It's when you second guess yourself and you're not sure of that second guessing yourself. That's when you're wrong.
I don't like second guesses outrageous.
Yeah, when you're on a test, either if you're decently okay with doing it, go with your gut. All right, so yeah, multiplying fractions, multiply just straight across. 2 times 4, we get an 8. 3 times 5, we get a 15. This will not reduce because 8 is just, if I broke that down, it's, well, 2 times 4. There's a bunch of 2's in there, really. And with the bottom one, there's a 3 and a 5. So there's nothing common on top and bottom that would reduce by at all. So 8/15 is where you're stuck. Well, that looks like a terrible place for number 9. Let's just put it right there in the middle of the side of 7 and 8. That's probably the worst place to put something. All right, so number 9, I'm just gonna go ahead and do because I'm gonna blindly assume that people had questions on it. I might be right, I might be wrong. I don't know. So 2/9 divided by 3/5. The main trick of dividing fractions, again, you don't. You change it to multiplication and the second one flips upside down.
See that helps. Close that
Yeah.
and taking them out.
Yeah, you usually only suffer through a couple of the multiplication division ones. That, because am I wrong to say that the multiplication and division are a little bit easier to do than the addition and subtraction? So I mean, you just go straight across. When it comes to adding and subtracting, you gotta find a common denominator, you gotta make that happen, then you can go across.
Why'd they make it like that?
Because that's just how it happens to work out.
Says who?
Math, because if you can prove it a different way, then 1, you will be very rich, and 2, you will break math in the most spectacular way. And everyone will be very fascinated. All of math is basically just observation and basically tried and true methods of, hey, if I work out something in this method, it'll end up this way. It's all just observational. It's not something that people necessarily made up out of nothing. It's more they took something and found the rules that made it make sense. So, kind of funky. But yeah, like I said, if you could add 1/2 and 1/3 in a way that doesn't involve getting a common denominator, I'm down.
Just in fraction, we have this problem
Pretty much, yeah.
because we have the sign of division and we end with multiplication.
Well, with division and multiplication, it's not so bad just because you can go straight across, right? So those are pretty doable. It's when we have to get the common denominator, it gets a little trickier. And there is a method. There's a way to find a common denominator specifically on paper that can be done, but it's honestly just really long. And we will do that. It's in here somewhere. I'd like to say Thursday, but probably next Tuesday. We'll do it in a week. It'll be great. By the time we do that, you won't even be thinking about reducing fractions. Okay. Moving right along. First of all, before I move right along, anybody have any more questions on any of these or any concepts that I've covered? Multiplication straight across, division, flip the second one, and then go straight across. Adding and subtracting, common denominator. Add and subtract across the top, Across the bottom, you have the same denominator. Now, you might say, hey, it's math, it gets complicated. Are there any exceptions to this rule? No. Absolutely not. I like to explain everything in a way that it scales up. No matter how complicated something can be, you can always compare it to the most basic form of that operation and it should work. Even if you have the biggest, ugliest math problem the world has ever seen, you can absolutely still follow the same basic concepts to get to the answer. Every time, no exceptions. It might be trickier, it might be uglier, but it'll work. Okay. Now, let's go back to mixed fractions existing and how to convert back and forth with improper and proper mixed and all that stuff. So again, mixed fractions are a combination of a proper fraction and an integer. So when we have an improper fraction, the main reason you would want to convert from an improper to a mixed fraction is just if you're answering like a word problem, if you need something to better visualize it. Gonna drop my pen. And I'm standing now, whoop-de-doo, okay. Yeah, just improper fractions are often a little tougher to visualize. So mixed fractions or, you know, anything along those lines are generally better to visualize. Now, usually, I hate mixed fractions personally. I'll go with decimals any day of the week. It's quicker. It's just as easy to visualize. That's just kind of how I like to roll. But they do have their purpose. So being able to convert back and forth is kind of useful. So converting from an improper fraction to a mixed fraction, honestly, not too bad. The paragraph there might be a little dizzying. It says divide the numerator by the denominator, and you take note of any remainder. So for our example, we have 13 over 7. If we are converting that to a mixed fraction, you are going to say, okay, how many times does 7 go into that 13? Just kind of like long division, once, right? and then you'd have 6 left over. Well, with long division, technically the remainder is still over what you were dividing by. It didn't divide, right? If something didn't divide in, then it's still in there. So 13 divided by 7, you'd say, okay, 7 goes into there once. You have a remainder of 6. Okay, so we have a 1, and that remainder, the 6, is still over that 7. So that's what you end up doing. You just take that 1 out, and the remainder is what you put back into the fraction. So we have 1 6/7. Pause for dramatic effect. All right. Now, you can also go the other direction. Now, this is a little trickier to understand, but it's actually quicker to do. And what you end up doing is basically shorthand for adding fractions. And I'll show you how that makes sense when we do the first ones. So what you end up doing is you basically are doing that backwards. You're saying, okay, we have 1 6/7. How do I get that back into an improper fraction? And you're going to take that integer, that whole number that's out front, you're going to multiply it by the denominator of your fraction. So you're going to have 1 times 7. You're going to take that and say, okay, I got a 7. What's already in the fraction? 6. You're going to add that to it. So whole number multiplied by the bottom of the fraction, you take whatever that is, add it to whatever's in the fraction already. 1 times 7 is 7, plus 6 is 13. Now, the way I have it at the bottom, that last paragraph is basically why this makes sense. What I've done by this method, so I don't know if this is actually written this way in math books, but that's just kind of how I do it. What I've done by this method is basically shorthand for this last sentence here. If you're trying to convert them to an improper fraction, you're basically adding two numbers together. You have a 1 plus 6/7. So you take that 1, turn it into a fraction, 1/1, you get a common denominator and you add them across, just like the last bunch of examples. But that takes a while, and I don't want to. And you end up just doing the same thing anyway. You end up taking that 1, multiplying it by the denominator to get a common denominator, and then adding it to whatever's on top. So I made a shorthand version. So we just have a shortcut. I like a shortcut. Shortcuts are great. Let's do some. Are we excited by that prospect?
We see.
None of you are excited. I'm disappointed. I'm unhappy with all of you. I just want you all to know that. I'm just writing them all down. Well, at least the left ones. Okay. So we're going to convert these to mixed fractions. So again, the way we do this, and it's really quick. Stare directly at what I'm doing because it's quick. Okay, so we got 5, 12 divided by 5. How many times does 5 go into 12?
2.
What's left over? 2, right?
Yeah.
Okay, that's it. So you see how many times that 5 goes in there? Well, 2 because of the 10 essentially, and then you'd have 2 left over. That's still in the fraction. That's it. That's all you got to do. Isn't that fun?
Looks fun
I don't believe you.
when we don't, so we don't. I don't have the idea what to do.
Don't worry, I'll make you guys do some on your own soon. I know you're all looking forward to that. All right, so 14 divided by 3 or 14 over 3, however you want to look at that. Same thing. Fraction, division, same thing. How many times does 3 go into 14? 4. 4, right. And that would account for 12 of the 14, so we'd have 2 left over. 4 2/3. I like it. It's quick, simple. You're all gonna forget it in like 5 minutes. It's great. It's how it works, right? It's how all of this works. All right. 50 over 7. Goes in 7 times, because 7 times 7 is 49. Remainder is 1. Still over that 7. Beautiful. Effort. Love it. And 35 over 6. We got a 5 because 6 goes into 35 times. We have a 5 left over. Okay, that's it.
You're gonna make it do it?
Oh, don't worry, it has its own slide. We got our own slide for that one. The other ones, That's the crappiest looking 5 I've done in a while. All right. Looks sad. Lost its home. Gonna write down 5 through 8 real quick. Okay. This one, well, these ones, I should say. We're going the other way. We got 2 4/5, and we're going to convert that into an improper fraction. What was that?
2/5 over 4/5.
Not quite. So there's a couple of ways you can look at it.
Yeah.
Now I'll show you the long way and then I'll show you my shorter way. So what you would do is you would think of this as having a plus in between. That's essentially what you're doing is you're taking 2 separate numbers and you're putting them together. Now, in order to do this addition, this would have to be a fraction. So I'd put that over a 1. And then we'd have to do our usual. We'd have to get a common denominator. So we'd have to have them both over 5. So I'm going to multiply this one by 5 over 5. We would have 10 fifths reduces to a 2, so it's the same thing, plus 4 fifths. We now have a common denominator, so you'd put that over 5, 10 plus 4, 14. So it works. And yes, you can get away with doing it this way every single time. However, I don't want to do all that. That's a lot of writing. I don't like it. I don't like effort. I'm a very lazy human being. So what I would prefer to do is between these 2 numbers, I'm going to multiply them. And then whatever I end up with there, I'm going to add right here. So what I'm going to do, 2 times 5 is 10, right? So you take that and you add it to the top. 10 plus 4, 14. And you would still have it over the same number, that 5.
And that's gonna work every single time.
Yup,
Yep.
yeah.
Nice.
I like my shortcuts,
I couldn't even, I was trying to start at the top one, but this was nice.
right? I like my shortcuts. So again, take that integer, multiply it by the bottom, add that to the top. Put it over the same number. We're good. Let's try doing on this next one. We have 6 2/3. So we're going to do 6 times the 3, 18, right? Plus what's on top, 2. 18 plus 2 is 20. And it's over the same thing. And for the purposes of notes, I'm going to write below it what I just did. This is 6 times 3 plus 2. And it's still over that 3. But yeah, that's it. That's all you have to do. And it makes sense because if you look back at the way we did it the first time, the long way, well, what did we do? We had to get a common denominator. To get that common denominator, I multiplied it by, well, basically the bottom, right? I multiplied it by the bottom, and then I had a common denominator that I could add across. That's all I did. This number times the bottom added to the top one. So I just made it happen all at once.
How did you come across that cheat?
I don't remember if I read it somewhere or if I just pulled it out of thin air. I have no idea.
If you pulled it out of thin air, you should have made money off of it.
This is not something I could make money off of. For God's sake, when I was working at GameStop, we had to hire one of the history teachers so he could survive the winter. All right. This is, education is not gonna make anybody money. Ugh. Went to a university for a while, almost never saw any of the actual teachers, everything was done by TAs. All the actual professors were getting paid for research, they weren't actually teaching. Really sucks. All right. Hey, look, number 7. We have 14 3/10. Okay, 14 times 10 is 140. 140 plus 3. I like that. That's 143. That's still over a 10. Effort. Love it. Number 8. 13 7/11. Of course, I had to put a 7 over an 11. Yeah. This is America. All right. Yeah, so 13 times 11 is awkward, but yes, it's 143. Plus that 7. 143 plus 7, we end up with 150. Still over that 11. There we go. Now, one thing I do want to say, it's not directly applicable to this stuff, but one thing I do want to say is that sometimes in math problems, you do get really weird looking improper fractions as an answer, and that doesn't mean they're wrong. It just means it might be a weird answer. There's one problem in either Math 95 or 96. I don't remember. I don't know. They ran together. But one of the word problems in one of the sections had an answer that was 101 over 2. And every single semester, I had at least 5 people come up to me in the tutoring center and ask me, hey, I had to have done something wrong on this word problem. I got the weirdest, is it 101 over 2? Yeah, okay, you're right. I didn't even tell you which one. No, I know it. They kept that problem through so many additions, doesn't matter. It was a weird answer. Nobody ever trusted they were right. Sometimes you just get a weird looking number. That's okay. All right, so how do we feel about converting to and from proper and mixed fractions?
Good.
Pretty decent.
Practice it a little more.
Oh, you say you want more practice?
I'm down.
Oh, that's good. All right, you guys do a bunch. Oh, you were going to anyway. Perfect setup. Oh my God, I loved it. I loved it. Well, the only reason there's 6 problems is you saw how quick I did 8. And that was me explaining all of them. So, I mean, you guys can pull this off. I believe in you. So only 3 of each. You got this. Again, if you have questions, ask me. We are going to go over them afterwards.
Yeah.
Try to shut up now. It's very difficult for me.
Josh, turn that shit down, dude.
Yeah.
Oh, I thought I was on mute.
Hey, man, I have every intention to comment on everyone's personal lives at all times. I have no regrets.
No regrets.
I should get a no regrets tattoo.
I said, I swear. I said, I swear on the perfect God. We've learned a lot of stuff this year. It's kind of wild. Perfect. Actions, right? Multiplying big numbers, dividing big.
You always can. Feel like everybody who's come tonight is in the restroom. So I'm just gonna wait till y'all get back.
Another thing I noticed that I've really had, always had trouble with the word problems too.
Mhm.
We would cover that too.
I do need to have some more word problems in the exercises, I will admit that. I don't have a whole lot of examples to them, but I could dig through some books, you know.
You don't have to add any if you don't want to, it's fine.
Well, funny
Yeah,
enough.
I agree with Robert.
Hmm.
Don't listen to Joseph.
There's literally
Thanks, Rob.
the immediate thing of everybody's telling me they don't want to do that makes me feel like we need to do that.
Oh, well then, yeah,
Um,
you should definitely do that. Like, 100%.
I mean, if it makes you guys feel better. Hey, look at all the next stuff we're gonna be doing.
Oh my God.
Oh, there we go, yeah.
Yeah, look at that, yeah. Yeah, we
That's
like
nice.
that.
I'd rather do word problems then.
It's okay if it makes you feel better. We will also be doing weird stuff like this. What else do I have in here?
3 times what? So that, what is it?
What about it? We'll get there.
Will look familiar there.
Ooh, look at that, even more word problems.
Yeah, see, you don't need to add any. We just haven't gotten there yet. So you're good.
I could add
I
more.
agree with Robert now.
I could add more.
No, see, that one's no. You're good.
Ooh, look at that. That'll be fun. Hi, Johnny Bravo.
There's man.
I love Johnny Bravo.
It's a little bit-
Basically have like the next 2 weeks in this one slide. RoboCop. Half man, half robot.
Isn't that what Data is?
Oh,
Data. Star Trek. Really?
Data.
Yeah, isn't he RoboCop?
I mean, he's just straight up a robot.
Oh.
He was made from scratch. I may or may not have seen every single episode of Star Trek. Here's actually, I usually swap out my memes every time I teach a class. This one I keep on here every single time because it cracks me up every time I see it. This is literally something that happened in an episode of Star Trek. I did fall asleep reading a particularly erotic chapter in my grandmother's journal. That's gross. That's the plot of the episode has her sleeping with a ghost that was the same ghost that her grandma slept with. That,
Keeping it in the family. That's good.
yeah, right. It is,
At the pure bloodline, right?
So since you're a Star Trek fan, have you seen Galaxy Quest?
I have Galaxy Quest on Blu-ray. Did you know that there was an alternate audio track on that Blu-ray that has just the weird alien gibberish? The
No way.
entire, yeah. Somebody's job for that entire movie was to just sit there.
They could have paid me.
Right? That movie, I've actually seen it in like Star Trek meme groups, like, okay, knowledge is knowing that Galaxy Quest is not a Star Trek movie. Wisdom is knowing it's the best one. It is honestly one of the funniest movies I've ever seen in my life.
That one and Evolution.
Oh God, I used to love Evolution. Oh my God, that was such a profoundly stupid movie. It was
Yeah.
great. You know, my favorite thing about Evolution is that was the first time that the Army general, the first time I seen him in a movie for quite some time, and then he ended up being the police captain on Monk. But
Yeah.
he couldn't get a job for a long time until he grew that mustache because he was Buffalo Bill in Silence of the Lambs.
Yeah.
And he creeped everyone out too much. So he
Didn't
could
really
not
get
get a
a
job until he grew that mustache. It was awesome. All right,
Let's review.
let's do math. Let's do math. Let's look back. So how did everybody do on these? How do we feel about these? 100%?
Yeah.
Most likely.
We got some confidence in here. How about you silent people on the internet?
I think I'll be fine.
Okay, that's good. That's good.
Easy.
Anybody have any questions on any of them? Oh, I just wrote them all down.
Oh.
Yeah. You'd think I would have done this during the time I had you all be quiet and looking. No, that wouldn't make sense. I'm just gonna run through them real quick, just to make sure that we're good.
The fuck?
I think that's right. Yeah, cool. All right.
So far, so good.
All right, we're happy with these numbers. Yay. All right, that's wow, my fraction bar turned into a 7. You know, the problem with ADHD is not that I have trouble, like, well, I do have trouble focusing. It's that I try to do everything all at once. It all just fires all at the same time, and it just sucks that way. Let's see. Remember, kids, if you give your kid Ritalin and he starts going crazy, I'm sorry, but he doesn't have ADHD and you just gave him speed. It's the truth of it. Ritalin is speed. When I was a kid, it used to put me to sleep. I used to shove it in our little flower bed out front of our house. If I had realized that, you know, people would have bought it, I probably would have become a dealer as a small child. Not even gonna lie. I wonder what that did to the soil.
No.
Made everything grow super fast.
Yeah,
Yeah, I got 100% for sure.
cool. I like it.
Thank you.
Yeah, I hate coffee because it used to be a punishment for me. 'Cause it'll knock me the hell out.
See, I remember going as a kid in Mexico with my parents, and I would take a Monster because I want to stay with my dad.
Ooh, yeah.
Right back to sleep.
I actually dropped, I think it was a geology class, never tried geology ever again because it was the first time I ever had a Red Bull. I was like, okay, I'm too tired. I'm gonna drink a Red Bull and that'll keep me awake. I literally was just struggling to open my eyes. I barely made it back to my dorm and just kind of went. And then I woke up and dropped the class because I thought it was geology. I thought I just hated it that much. No, just can't do that.
Steve would calm me down.
Now, Mountain Dew.
Back in my day.
Yeah. Mountain Dew, got enough sugar, got enough caffeine, balances quite nicely. Hello. Freaking asked me to go to the bathroom and you're answering the phone in the classroom. I don't understand how that goes together.
My grandma.
Okay, well, if it's your grandma, yeah. If it's actually your grandma, I'm cool with that.
Yeah.
I don't have any of those left, like,
It's okay, I don't got no grandmas.
you know what? I had one, he was a jerk. He dropped dead walking out of a rest stop bathroom. So I guess, you know, if you gotta have a heart attack and drop dead, because, you know, you empty out, might as well be right after you do it intentionally, right? Okay, he
I
sucks.
feel bad for laughing.
You're good.
I'm laughing at the clouds about it.
No, you're not, Joseph. Don't lie. You ain't gonna lie to kick it.
20 years, he's good.
We're good.
Yeah, he's good. All right. Hey, look, I'm teaching math. What do I have here? Unit rates, proportions. I would like. Well, what slide are we on? We're on 18. Taking 2 hours to go through 16 slides.
I think that'd be normally on.
Question, all right. Oh, God, it's my handwriting, it's awful. All right. I don't know, what was this? 22. How far did we get in this one? 26. Ooh, that was hardcore. Only got through 18 so far. I don't know if I can get through all of this. I don't know if I can get through all of this in the next half hour, and I want to cover the next 3 concepts at once. So I'm gonna call it. We cool with the shorter night tonight? Oh, you're definitely happy about this.
I'll start computer work as soon as I get home.
Sounds good, sounds good.
Is there not a? It's just that
The essential ed,
yeah,
Yeah.
that for you it's just essential because I know the English teacher has something else with all over the side and stuff.
so, yeah, I got a full-time job outside of this, so that is all that is happening.
Me too. Thank you.
I
appreciate you taking.
Yeah. But yeah, you guys are good for the night. Do some essential ed if you can. If you can't get into it, shoot me an email. I'll either, figure out what your user and password is or send you to someone who can. But for now, yeah, we're gonna call it good. We're gonna start off next time after review with ratios.
All right, then you take care.
Okay.
All right, good night.
Everybody have a magical evening. I'm going to go home and make tacos.
Okay, bye.
Tacos. All right.
Have a good night. Have a good night.
You too.
Okay, Ben, so have a good night.
Always, and I hope you do too, my friend.
Okay, thank you. Was a interesting class today.
Oh, don't worry, we'll make it worse. You know that.
Yeah, okay, thank you.
Yeah, later.
Bye.